Okay, hi Zach, welcome to lesson number 63. Today we are going to go over the product of square roots rule, and we're going to go over repeating decimals. I think, right? Yes, that's, yes, we are. I guess we are. I don't think that I planned for that, but that's okay. We'll just jump right in. All right, so first of all, is algebra class important to you? Algebra class will be important to you later in life because there's going to be a test 6 weeks from now. I don't think that's what kids mean when they ask that sort of question, but definitely in the, during this year with all your tests, it's going to be important to you, but hopefully it's also important to you in the future. All right, so here we go. Square roots of many numbers like this, and like this can actually be written in simplified form. So to write one of these numbers in simplified form, we're going to use a new rule. And I call this rule the product of square roots rule. Product of square roots rule. So what it says is, if m and n are non-negative real numbers, then the square root of m times the square root of n is equal to the square root of m times n. So basically, if it's outside of, like if it's two separate square root signs that are multiplied together, you can push them together and include them in one big square root sign. And I'll show you why that's actually important. And what's interesting is you can do the opposite. So if it's two things inside a square root sign, like this times this, you can actually separate it out. This is what we're going to do in today's lesson. Then you have the square root of m times the square root of n. Okay? So that is important. That is the product of square roots rule. And not only that, but the rule can be generalized. That means like it doesn't have to be specific. It can be generalized to the product of any number of factors. So it doesn't have to be just an m and an n. It can be the whole alphabet. You can have a buttload of factors under the square root sign, and the same rule will work. So we say that the square root of any product can be written as the product of the square roots. I know that's complicated. It sounds complicated until we actually do it. But it can be simplified to this. The roots of the products is equal to the products of the roots. And I put some produce here, because it's kind of like products. And they happen to all be root vegetables where you eat the roots. So the roots of products is equal to the products of the roots. The roots of the produce is the produce of the roots. The roots of the produce is the produce of the roots. I know, it's catchy, right? You're going to remember it, I'll tell you that. So here's what it means. It means if you've got a square root sign over this whole thing, 2 times 5 times 5, you could simplify it to this. The square root of 2 times the square root of 5 times the square root of 5. It doesn't seem like it's any better in this form, but, if one of these actually has a square root that's not a weird number, then it does make more sense. I'll simplify it, don't worry. Then this one is the same. A square root over 3 times 3 times 3 times 5 is equal to the square root of 3 over the square root of 3 times over the square root of 3 times the square root of 5. All right, I know, we got to just do some examples. Yay, examples! All right, here we go. Let's do example 63.1. This is on page 258, and it says basically just simplify. So it says simplify, and it gives us this. So what the heck do we do with that? So what we do is we write the number 50 as the product of prime factors. Now, sometimes that's hard for me to remember what to do with that, but I know that 50 is 5 times 10. So I can do that. And then I can simplify 10 into 5 times 2. And then I have it broken down into its factors, 5 times 5 times 2. So the square root of 50 is going to be equal to the square root of 5 times the square root of 5 times the square root of 2. Because I can take these three things, 1, 2, 3. 50 is 5 times 2, right? So let me make this a little easier to see what's happening. 50 is 5 times 2. So it's basically the square root of that whole thing. Get it? So this is the same as this because of the produce of the roots is the roots of the produce, right? So then we've got the roots of all the products, the prime factors, okay? So then we can simplify it further because remember that this part here is the definition of a square root. So the square root of 5 times the square root of 5 can be simplified to just 5. Does that make sense? Because if you are multiplying it by itself, then what are you actually doing? You're squaring it. It's like you're taking 1 and you're squaring it. And if you take 1 and you square it, then the answer is this. Does that make sense? But we can't do that with the square root of 2 because we only have one of them. So then that just comes down and becomes the square root of 2. So this is the answer. This is the final answer. Okay, hopefully you understand that. Let's go into example 63.2. Impossible to see the future is. You've got to do all these examples. That's what I am trying to say there because the examples get more complicated and then your homework gets even more complicated. So if you don't do all the examples, you won't quite get it, okay? So let's jump in and do the next example. It's 63.2. We have to simplify this, the square root of 200. So if we simplify the square root of 200, the first thing that we're going to do is take 200 and write it as a product of prime factors. I have to still do this because, I don't know, I'm not as smart as you. So I'm going to do 2 times 100, okay? And then 100 is going to be 2 times 50. 50 is going to be 2 times 25. And then 25 is going to be 5 times 5. Okay, so now I've got all my prime factors. It's all of these, right? Okay, so the square root of 200 is the same as the square root of, sorry. Let's try that again. Okay, it's going to be the same as the square root of 2 times 2 times 2 times 5 times 5. Okay, and then this is going to be equal to the square root of 2 times the square root of 2 times the square root of 2 times the square root of 5 times the square root of 5. That's a tongue twister. Now, anytime it's squared, like this and this, then it just ends up being a 2 right there. And this just ends up being a 5 right there. This one, because there's only one of them, that one has to stay. So you end up having, let me get a different color, 2 times 5 times the square root of 2. And then that can be simplified further as 10 times the square root of 2. And this is the format they want it in, and that is the final answer. Alrighty, that was kind of fun, huh? Kind of satisfying. Let's do example 63.3, but first let's look at this. Okay, so there's a guy working on a missile here that says missile. Looks like he's been planning it. And this guy, look at this guy, he's gonna play a practical joke on him. Oh, I feel bad. And I don't know what's gonna happen. They might all blow up. That is so sad. Okay, all right, that's hilarious. Let's do this one. This one is a little bit more complicated because it's the number 147. So we've got to break that down into its products or prime factors or whatever. So the first thing I do is, if it's an odd number, is I see if it's divisible by 3. And do you remember how to do that? You add the digits, 1 plus 4 plus 7. So what is that? 7 plus 1 is 8, 9, 10, 11, 12. So the digits add up to 12, and 12 is divisible by 3. So then I have 3 times something. What's 147 divided by 3? Let me get my calculator out. You probably already know this. 147 divided by 3 is 49. Oh, 49. I recognize that number because that is a very common multiplication problem. 7 times 7. Okay, so now I've got my primes. I've got 3, 7, and 7. All right, so 147 is equal to the square root of 3 times 7 times 7. Okay, and I'm going to go ahead and erase this nonsense. Alrighty, so this is also the same as the square root of 3 times the square root of 7 times the square root of 7. And this part can definitely be simplified because it's the same as this squared, right? So that squared is just going to reduce down to just a simple 7. So then what it all boils down to is 7 times the square root of 3. So it's usually written in this format. So the square root comes after, and you write the regular whole number right there. That's how it's usually written. All right, let's do one more. One more. We got this, right? Let's look at this cartoon. It's called Mathphobic's Nightmare. Mathphobic's Nightmare. Okay, so it looks like a guy showing up at the pearly gates, and this guy is saying, okay, now listen up. Nobody gets in here without answering the following question. A train leaves Philadelphia at 1 p.m. It's traveling at 65 miles per hour. Another train leaves Denver at 4 o'clock. Say, you need some paper? That is truly a mathphobic's nightmare. Like, you can't get into heaven unless you ask that question. I thought the question was going to be like, have you been good or something? But that would be much more difficult. All right. Well, I don't know. I don't know which question I would rather answer. Have you been good or do the math problem? I might do the math problem, actually. All right. Let's break down 108. Now, this one is an even number, so I'm going to start with 2. 2 times what? It's going to be 54. That's another even number I can break down, which is 2 times what? 27. And then 27 is 27 is not, you can divide that by 3, right? So you can do 3 times 9, and then the 9 breaks down to 3 and 3. So what are my primes? My primes are 3, 3, 3, 2, 2. Okay, that's it. So let's write that. So the square root of 108, I'll put that over here, is equal to the square root of 2 times 2 times 3 times, there's 3 3's, times 3 times 3. Okay, so now let's see, square root of 2 times the square root of 2. And then you've got the square root of 3, the square root of 3, the square root of 3. Alrighty, now let's break this down. This can go to just 2. This can go to just 3. And then this has to come down as the square root of 3. So underneath it, I've got 2 times 3 times the square root of 3. And 2 times 3 is 6 times the square root of 3. And that is the final answer. And yay, it even matches the answer in the book. So that's good. Okay, guess what? I forgot to do a section here. And the section is the section on repeating decimals. So let's go ahead and just go over it. So this is on the bottom of page 258. And what it says is when we write a number like this, 0.3, with a line over the whole thing, what that means is the 3 repeats. 3, 3, 3, 3. And you can write that for your entire lifetime. And you will get closer to what it actually is, but you'll never reach it because it's infinitesimally long. The bar over the 3 means that the 3 repeats. Okay, now, numbers that have a repeating decimal are called rational numbers. So you remember all those categories, right? And rational means that it can be expressed as a ratio. It can be expressed as a fraction. And there are some fractions that give you a repeating decimal that they want you to just freaking memorize, okay? And this is actually one of them. All right, so here are the numbers that they want you to memorize. 1 over 3. Put that one in your memory banks. So if you plug that into your calculator, what do you get? You get what we just did, 0.3 with a bar over it. Plug it in. You'll see what you get. It'll be 0.3333 forever. I ran out of space there. So commit that one to memory because that one should be known. All right, the next one that they want you to know that must be burned into your retinas is 2/3. 2/3. So if you plug that into your calculator, go ahead and do it. You will get 0.6 with a bar over it. The 6 means I should put a 0 because that's by convention. There should be a 0 before the decimal. 0.66666. This is the devil's number. Woo, okay. So 2/3. Remember that 2/3 is the devil's number. Alrighty? So there you go. And let's do another one that they want you to commit to memory. Remember it. I'm sure it's going to show up on tests. The next one is 1 over 9. 1 over 9. So how are we going to remember this? 1 over 9 is 0.1 with a bar over it, with a bar over the 1. I'm going to kind of remember that it's 911. Will that work? I don't know. Let's try it. 911. What you really get is 1, 1, 1, 1, 1, because the bar's over the 1, right? So good thing that that's not the 911 number, because then you would be dialing that into your phone forever. 911111111. So 1 over 9 is 0.111111111. Say that 10 times fast. All right, let's do the next one. The next one is that you have to memorize 1 over 6. This is also the last one, so don't worry. 1 over 6 is interesting, and I think you'll be able to remember it because it's the same digits, 0.16. But the 6 has the bar over it, not the 1. The bar is only over the 6. So what does that mean? That means that when it repeats like this, 1, 6, 6. Only the 6 repeats, not the 1, 6. So 1 over 6 is 0.16, and the 6 repeats forever. Okay, so think you can remember those, commit those to memory, and I don't really have a GIF at the end, so I'll just say, have a great day, have fun, and good luck with your math and your rest of the day. Okay, love ya, bye.